Today we will be talking about factoring the differences of squares. So in other words, this is going to be really easy because compared to what we've been doing. So what you have to do is first of all, realize that if you have a situation where you have a squared minus b squared, it will be equal to the product of a minus b and a plus b. So, for instance, a squared minus 64, that will be factored a minus 8 and a plus 8. Okay, because 8 is the square root of 64, and a is the square root of a squared. Okay, another example. Let's see. N squared minus, let's say, 121. Okay, that would be equal to n minus 11 and n plus 11. Because 11 is the square root of 121 and n is the square root of n squared. So that's pretty simple and that's pretty straightforward. There could be coefficients in front of some of these, so let's take a look and see what would happen if we did that. For instance, if we had 4m squared minus 64n squared, then you would take the square root of the first term, the first monomial, and that would be 2m, and subtract the square root of 64n squared, which would be 8n, and then multiply it by 2m plus 8n. Okay, so the two binomials that you're going to get after you do the factoring will be extremely similar. The only difference will be the sign. One will be minus and one will be plus. And you can see that minus and plus, and that's the way this formula is written. Okay, so this only works for the differences of squares, so be careful. If this had been a squared plus 64, we couldn't do it this way. Okay, it's because there's the minus sign there, and we're talking about the differences of squares. Okay, let's look at another example. This one is 50. Oh, I have to switch back to the pen. 50a squared minus 72. Okay, and when we look at this, we might look at it and say, oh, well, this isn't that situation because 72 isn't a perfect square. 64 was a perfect square, and that's why this worked. 121 was a perfect square, and that's why this worked. 64, once again, 8. Okay, but 50 is not a perfect square, and 72 is not a perfect square. So what can we do in this situation? Well, it's always a good idea whenever you see a quadratic equation to try to see if there's a GCF that you could pull out. And in the case of 50a squared and 72, we do have a GCF. We have a GCF of 2. So that would be step number 1, would be to pull out the GCF and say 2 times 25a squared minus 36. Okay? And then now when we look at what we have, the binomial that we're left with, the 25 is a perfect square and also 36 is a perfect square. So now we can go ahead and apply this rule to this part of it. Okay, so then we'll say equals 2. We'll just leave that 2 out in front, and we will take the square root of 25a squared, which is 5a, minus the square root of 36, which is 6, and then we'll do 5a plus 6. Okay, so if it doesn't appear to be a perfect square on this particular worksheet, then what you need to do is to try to pull out a GCF and then see if that will work. The other thing that you need to be prepared for when you get down to, say, like number 13, for instance, on this worksheet, that some of these powers will be higher than to the second power. They'll be to the third power or to the fourth power. Well, once again, don't get confused by that. Number one thing is see if you can take and find a GCF and pull a GCF out, because that might take care of your problem. For instance, on number 13 on today's worksheet, you have 4x cubed minus 100x. And you might say, okay, wait a minute, I've got an x cubed, what do? I don't know what to do, I can't take a square root of an x cubed. But if you can see, both terms have an x in it, so x is actually part of the GCF. The GCF for this is actually 4x. So when we pull the 4x out, we're just left with x squared minus 100, and both x squared and 100 are perfect squares that we can take the square root of. So then you could continue on from there. The same thing with number 14, for instance. Okay, we have 2y to the fourth minus 32y to the second. Okay, let's pull out the GCF. 2y to the second is the GCF. So after we pull that out, we're left with y squared minus 16. Let me correct that. 16, okay? And y squared is a perfect square, and so is 16. So now you can go ahead and use the formula for the differences of squares on that. And then what if, let's say for instance, let's look at number, trying to see one that's like this. Number 10. Number 10 is an interesting one. And you might be saying to yourself, okay, y to the fourth, what do I do? Well, okay, this isn't an example. Number 10 is negative 81 plus a to the fourth, and there is no GCF there between those two monomials. So what we're just going to do is we're going to look at it and go, well, but that's okay, because a to the fourth, I can take the square root of a to the fourth and get a squared, and I can take the square root of 81. So you probably want to rewrite it so that it looks like this, and then just go ahead and, take the square root of each of those, and then you're done. Okay, so, that's kind of, so 13 and 14, realize here, I didn't finish those for you. You're going to need to go ahead and finish them. I was just showing you how to get them started, how to pull out the perfect square, how to pull out the GCF, and then you're left with two binomials that are perfect squares. So that's today's lesson, and hopefully this will go well.